everyone. Welcome to this training video on how to size water distribution lines for small water utilities. Whether you're serving a small town or a rural area, designing the right pipe sizes is essential to deliver safe, reliable water and meet regulatory and fire protection requirements. For this video, we'll walk you through key sizing decisions using AWWA, American Water Works Association, and since I'm here in Tennessee, TDEC, including when to use 4, 6, or 8-inch lines, how to factor in fire flow, pressure, and future growth. In reality, these guidelines are adaptable for most any location in the U.S., but check your state and local standards, especially for fire flow requirements, as they can vary somewhat in different locales. All right, let's start with the core regulatory and design standards. According to TWWA, your system must maintain greater than or equal to 35 psi under normal conditions. You must maintain 20 psi or greater residual pressure during fire flow conditions. You need to provide fire flow of at least 500 gallons per minute for residential areas, and we'll talk a little bit more about that later. And you must use minimum pipe diameters 6 inches for mains with hydrants and 4-inch where no fire flow is required. Next, here's some of our factors we look at for sizing distribution lines. So it's going to be the number of connections, desired water pressure. We already talked about that a little bit. Fire flow requirements we'll talk about a little bit later, and future expansion. We all know we have a lot of growth in our different areas, and you need to plan for that because when you're stubbing in lines, it's going to be very important. All right, so let's talk about system demand. For a system of up to 1,000 mostly residential connections, which is the scenario we're looking at here today, and really this applies to pretty much anything, but we're really focusing on mostly residential connections and maybe around 1,000. So a small water system type of situation. So we're going to look at an average daily demand of around 250 gallons per day per connection. That's generally what we see for most households on average. Now, if you have a big lawn and you're irrigating and all that type of stuff, it can be more. But generally for planning purposes, that's what we look at. Maximum daily demand is 2 to 2.5 times the average. And peak hourly demand is going to be around 3 to 4 times average daily demand. Peak hourly demand is going to be that demand where everybody comes home from work and they flush the toilet or turn on their faucet. And so you're going to see a spike in your usage. So you need to calculate that out and make sure your system accounts for that, because that's not going to be just your 250 gallons per day per connection averaged over the lifespan of the day. You're going to have peaks and valleys. And so you need to account for that so that you got the water there to do that. Also, you're going to need to overlay your fire flow demands on top of these, especially during max day conditions. So this is what a demand profile would look like. We can see our average day, just bumps along there a little bit. We have our max day, and then you get your peak hourly demand. So like I say, that's when people come home and turn on the faucet and peak demand hits usage. Maybe in the morning, everybody's taking a shower and that demand rises. You need to account for that in your capacity and your pipe sizing. All right, demand versus pipe capacity. A key rule, normally normal velocity should be less than or equal to 5 feet per second. This stops the water from flowing too fast or too slow. It gets right. Water that flows too fast gets into turbulent flow, and that can create problems for your pipe as well. Fire flow velocity can temporarily reach 8 to 10 feet per second. That's during fire flow conditions. Now remember, you got to maintain a certain amount of pressure too. So this is what lines are going to look like. So a 4-inch line is going to be capable of 1.7 cubic feet per second, 6-inch 3.5, and 8-inch 6.3. So you can see you can obviously stuff more than that 5 cubic feet per second into a 8-inch line. So you need to kind of moderate that a little bit too. So your Flow and friction loss increase rapidly with smaller diameters. So, for example, a 6-inch main at 5 feet per second handles about 500 gallons per minute. An 8-inch main at the same velocity handles about 800 gallons a minute. So you can see the difference there. And desired water pressure enters in there too. So residential, we said greater than or equal to 35. That's a minimum. You really want 40 to 80 psi in your residential lines. You start getting below that and people start complaining. Business is going to be a little bit higher, 50 to 80 psi. So that's really what we're looking at here. All right, for a guide to use, here's basically a breakdown of when to use each pipe size. So for 4-inch, we're only going to use that for short, low demand runs. There's not going to be any fire hydrants allowed on those lines. It's going to be maybe 20 homes or less. Ideally, it's looped or flushed regularly. You don't want to have dead ends. We'll talk about that a little bit later too. Now, I will say here in Tennessee that for 4-inch lines, it's saying that they don't allow hydrants. They do allow hydrants, but in Tennessee, you need to paint those hydrants red and you need to notify the local volunteer fire department and the rural areas anyway, which fire hydrants are painted red because they cannot sustain the pressure. So they know not to use that for fire flows because it's not going to deliver the fire flows that they need. So it is allowed, but under certain conditions, and the fire department is not going to be using those hydrants. My point is, why even put them in? But sometimes they're there and they were already there and under lower pressures, they're not much good. The state of Tennessee requires they be painted red so you know exactly what's going on. So just a little caveat there. All right, 6-inch lines. Those are going to be standard for residential areas, especially for where you want fire flows and fire hydrants. They'll support fire flow up to 800 gallons per minute. They should be looped or limited in length if dead end. For 8-inch, we're going to use these for trunk lines, long runs, or commercial zones. They're going to handle about 1,000 to 1,600 gallons per minute. They'll provide better pressure and lower head loss, and they are ideal for future expansion corridors. We're going to want to reserve 10-inch or larger pipes for trunk lines or special needs, for example, source feeds or future large consumers to provide ample capacity and keep system pressures strong. So the 10-inch lines are going to be a little bit more rare. Generally, most of your mains are going to be the 8-inch, and then you're going to have 6-inch into residential neighborhoods where you're going to have fire flows. All right, so number of connections up to 20 for 4-inch, 20 to 150 for a 6-inch line, 150 to 400 for an 8-inch line. So you can basically see what our connections are here. Pipe sizing should be verified with hydraulic calculations, and the Hazen-Williams equation is the most commonly used method for estimating head loss. So let's look at that real quick. So the Hazen-Williams formula, and I got this, I want to give credit to Engineering Toolbox. They really had the best explanation. You're really looking at your pressure drop in PSI per foot of pipe. So this is important because what's going to happen is the pipe is going to create friction. You're going to get some friction loss in there. So you need to take this into account with your pipe sizing to understand that. So this calculation really tells you what you need to know here. So your pressure drop is that PD. C is going to be the design coefficient determined for the type of pipe or tube, and I'll show you in a second here what that looks like. The higher the factor, the smoother the pipe or the tube. Q is going to be the flow rate, and DH is the inside hydraulic diameter in inches. So these are and you got some coefficients there. You can see that you're going to do this calculation. So let's look next. These are the roughness or the C factor that's going to, so the higher the number, the lower the friction loss, or the lower the roughness, the smoother it is. So you're going to get a little less head loss from that. So you can see that probably the asbestos cement is pretty high. Polyvinyl PVC and fiber reinforced plastic are really going to be the lowest friction loss. They're going to be the smoothest. So steel is going to be 90 to 120, so fairly rough. So the ductile iron Those types of things are going to be fairly rough, and so you're going to get a little bit more friction loss. So you can see up here, those numbers cast iron will degrade over time. An older one is going to have a little bit higher friction loss. So that's something you need to look at there too. All right. So one of the things you'll need to do is model peak hour flow and fire flow scenarios. You're going to want to use conservative pipe roughness values, the C factor there that we just looked at, about 130 for a new pipe. That for PVC, it may be a little bit higher, but taking a little conservative factor in there to kind of basically look at it so that so you're not right at the limits there, and you're calculating for maybe some problems in the pipe and some joints and things like that might increase your roughness and increase your head loss. So coming up with a conservative number there too. So you're going to want to check if the pressure stays above 35 psi during peak hour and 20 psi during fire flow. So there's some tools out there to model this, EPA Net, WaterCAD, or similar. You can also do field testing, so hydrant fire flows to calculate the models. All right, now let's talk a little bit about layout. A good layout is as important as pipe size, because it really determines where your water goes and the efficiency of the use of that water. So the first thing we want to look at is dead ends. We want to use them sparingly, and we want to provide flushing. What happens is that dead ends tend to create stagnant water, so that you can get bacteria issues and things like that at dead ends. So if you have dead ends in your lines, you want to regularly flush those lines. We want to limit the length or number of connections on a dead end so that we don't deal with that stagnant water issue. Looping. Always loop when possible. It improves pressure, water quality, and reliability. It reduces head loss and service outages. All right, this is just kind of looking at the looping here before and after. So we want to build those loops in. You don't have to do the flushing then. And flushing, I can tell you, is a pain, because going around, getting those, cleaning out the lines, and even just pigging it with ice sometimes. I've seen people doing different ways to flush those lines. It's better if you're looped and you can plan for that up front, so it reduces those problems. All right, planning for growth. Stub out the mains for future expansion. Oversized mains where development is expected, and ensure hydrants and fire flows meet future needs. So this is going to be important, because you want to look at where your development is and you want to plan for that. Sometimes we can't plan, and sometimes these lines have been in for quite a while, so we need to account for that. But where you can, try to plan for future expansion. You have some growth areas, and that's going to be important. All right, now let's get into, this is just an illustration of just a reminder. So your phase development, so your planned stub, your existing future phase, these are all things you want to look at and plan for those stubs that you got in there, so that you can, and your pipe diameters, so that approximately how many homes or how many businesses are going to be in those areas, so you can plan that out and stub that stuff in for future use, size your pipes accordingly. All right, so future expansion, we want to look at the growth areas, and growth areas is going to be increased demand. The pipes need to be able to handle that. So that's why we're looking at the sizing and the pipe diameters. And of course, we want to look at things like growth projections, potential development, land availability, funding opportunities. These are all going to, sometimes just even doing demographic projections can be something that's important to look at as we plan things out, where we understand what areas can be developed, what the county general plan is that allows for development in these areas, what type of development. So these are all things we need to look at, is what is our development potential, and plan our pipes and our sizing and our loops to account for that. All right, so fire flows. Fire flows are based on the AWWA M31 standard and TDEC requirements. And just a reminder that requirements for your area may vary. We're talking about Tennessee here, and it's there's going to be fire flow requirements and different standards around the country, so you're going to want to check on that. Different cities, even have their own. So you got to understand what your local jurisdiction is and what requirements they have. And they vary here, even in Tennessee. Different cities have different requirements. So we're going to talk about some general guidelines, but my caution is to take this into account and to but understand what your local requirements are and what they're going to make you do. So hydrants require a 6-inch line. So you're going to need a minimum 6-inch line with if you're going to have fire hydrants. So any type of fire flow at all that's going to provide water for the fire department needs to have a 6-inch line that can support fire hydrants. Now, we already talked earlier about some exceptions that Tennessee has for low flow hydrants, but those are not to be used for firefighting requirements. So they're to be marked in red and they're not to be used. That's going to vary from state to state. I think Tennessee is really the only one I know that does something like that. I haven't checked them all, so it could be different places might have different requirements for that. But generally, the general rule of thumb is hydrants are going to require a minimum 6-inch line to support the fire flows. We're going to want to look at 500 to 1,000 gallons per minute for 2 hours. And we see some places where 500 is the minimum. And generally in rural areas, that's going to be acceptable where you may have 5-acre lots and you're going to bigger separation between houses. In cities and towns where the houses are closer together, you're going to want to push up closer to that 500. I've even seen 1,500 gallons per minute. And you probably want to have that for 2 hours. Now, keep in mind that you're going to need to maintain 20 PSI or greater throughout the system. So that's going to be important. So that's where your testing and your fire flow testing really comes into play because you need to test it to make sure you maintain that 20 PSI. It doesn't do you any good to have the fire hydrant in the water if there's not enough pressure there to pump water. And make sure your system can provide the necessary water supply. Now, if we look at 1,000 gallons per minute for 2 hours, that's 120,000 gallons. In these small systems, can you even provide that? That's going to be important to understand. Can you deliver that, maintain 20 PSI? And so if you can't, and you're planning to provide fire flows, you really need to take that into account. So there you go. Fire flow requirements. We're looking here at AWWA standards and TDEC specifications specifically because I'm here in Tennessee, but it's going to vary. They're going to be similar, but it's going to vary from jurisdiction to jurisdiction. All right. In summary, what we want to look at is use 6-inch lines as your standard for residential mains. Use 8-inch for loops, higher fire flows, and future proofing. Keep 4-inch lines for flushing and very low demand ends only. Remember, probably if you're going to have a 4-inch line, you want to have no more than 20 houses on that line. And you're always going to want to confirm your pressure and fire flow through modeling. And whether that's just releasing the fire hydrant and testing your PSI, it's important to understand that to make sure that you can reliably deliver those fire flows. You want to design for reliability by avoiding dead ends and planning for tomorrow's system. All right, so sizing water lines correctly is one of the best investments you can make in the long term for the long-term sustainability of your utility. And I'll tell you, it'll reduce your headaches so much if you really look at what your growth areas are, plan out that growth, have the proper line size you need to support the uses, the number of residences, the PSI you need, and the fire flows you need. So these are all important considerations. All right, so we want to look at flow demands and pressure requirements. We want to look at our fire protection needs, and we want to look at our future growth considerations. This is, in summary, that's what's going to really dictate what size lines you use. All right. Thank you very much. Obviously, in the interest of time, we have not covered topics like cross connections, backflow prevention valves, booster pumps, pressure zones, and the like. So those are topics for future videos. We wanted to talk today mainly about line sizing. So that's that. We'll add some videos on those other topics because those all enter in as well, and they're important factors and consideration for what we're doing out there in building our lines as well. And so we'll look at that in future video. If you found this video useful, please comment and share. It gets the word out to more people so we can continue to grow our audience and keep making these videos, which I like to do, and I like the feedback. And if we get likes and shares, that encourages me to keep making these videos. And also, I've left my contact information here on the video. If you have any ideas on videos you'd like to see for water wells and utility management, please let me know, and I will make videos, because if you're interested in that, other people are interested in that, I'm more than willing to do those and get that out for people. All right. If you're interested in water system management, check out our Water Masters training that covers so many things that you don't get in operator certification training. Basically, you're getting the basics on how to deal with the valves and disinfection and things like that. But as far as management, when it comes to asset management and capital improvement plans and things like that, a lot of that you do not need. Maybe you touch on it in operator certification training, maybe you don't. So a lot of that people pick up along the way. We're providing some training there to mainly focused on water utilities, less than 3,000 connections, small water utilities that can use this information and improve their operations. So that's it. We will see you next time in the next video.